is Shakti Madhavi from Skill-Lync. Today we are going to understand about draft analysis. As a design engineer, understanding about draft analysis is very essential. But why? Let us delve deeper into it. But before that, as a design engineer, you'll have an idea or a concept which you'll transform into a CAD model which is going to be produced using a mass production technique. So as a design engineer, it's not just about the concept design. You should have some understanding about product design as well as the production design. These are three different roles: concept designer, product designer and a production designer, which is where design for manufacturability comes into play. Every part that we manufacture has to be easily manufactured with very cost efficiency, with minimum lead time, and number of parts produced within a time frame should be optimum. These are some of the factors which we have to keep in mind whenever we design a part. So that is where draft analysis comes into play, very simply. So our focus is going to be mainly into the sheet metal and the plastic part, automotive sheet metal and the automotive plastic. Here the major manufacturing operation which we use is deep drying for sheet metal. We'll be using mold and tool for the plastic part. Then let us take the sheet metal. This is called the punch and this is the die. When a sheet metal is placed, and let us consider this is our desired model should look like. This is how it should look like. So the punch will push this sheet metal into the die so that our resulting model would look like this. But what if our model is like this? This amount of taper of our model with respect to the parting line is called draft. Draft is the amount of taper perpendicular to the parting line. Okay, and if it is at 90 degree, let us consider this is at 90 degree. Our mold is shaped like this. If I push the punch is also shaped like this. Okay, if I push my punch into the sheet metal so that the sheet metal occupies this die, if it is at 90 degree, when I try to take out the sheet metal from the die, there are going to be certain defects which occur in the model. If it is like this, there will be defects when I try to eject the model, be it in your sheet metal or the plastic part. There will be defects, and also the cycle time will be more, so the mass production will be affected somehow. But this is our solution, that is draft. We have to provide a positive draft. For a sheet metal model, it will be around 7 degree, and for a plastic model, it can be a minimum of 3 degree. This is an average which we use in our design, but depending on industry to industry, this value may change. So if this is like this, our model can be ejected easily, and also the number of parts that can be produced can be more because the cycle time is going to be less. This is a negative draft because this is not going to work. If a model has a negative draft, we cannot create a model like that. It is not manufacturable. So as a design engineer, you have to ensure that your model doesn't look like this. Coming to draft analysis, we have to ensure that the model that we create, each and every shape or the emboss that you create in your model mustn't have a negative draft. For that, if you use softwares like CATIA or NXCAD from Siemens, we have a draft analysis tool specifically where you have to start your model by creating a tooling direction first, starting with an end in mind. So we're going to start with the tooling direction, and we're going to create most of the surfaces or the sheet metal parts considering this tooling direction as reference. And finally, after you're done with the model, you're going to perform draft analysis and give a particular value. Say for example, in your industry, the minimum draft angle required is 6 degree. If you give 6 degree in your software, it will ensure that all parts of your model passes this draft analysis. If it is passing, your model passes the draft analysis and it can be manufactured easily. So this is where draft analysis comes into play, and as a design engineer, you have to keep in mind about all the manufacturing concepts and the difficulties which may arise when you do a manufacturing, so that they can be rectified during the initial stages of the design, so that we don't have to waste our time, resources, or labor in a wrong design so that you can create perfect design. So stay tuned for more updates.